Let's now say some words about the general case when we have n different node points in the x direction, at least internal node points, and the same in the y direction. The side lengths are 1 and 1 respectively. So let's go to the basis function vi, which has its node point here at node I. The pairing of vi with itself is in the same manner as for v1 equal to 4. So let's just illustrate this. Here is in this gray area we have the support of vi, and the intersection of the support of these two identical functions are of course the same region, and it's equal to 4. If we take the basis function close to I but at the right hand side and pair it with vi, we obtain that this pairing is equal to -1. The same if we go above this node point, pair vi with vj, which is has its node point at right above, then we get, as in the case when I was 1, we get -1 on this pairing. Similarly, if we go to the right, if j is a node to the right of this point, we get -1, and if j is below, we also get -1. So we can symbolize this with this figure. We are placing ourselves in this node, and we write 4 here, -1 to the right, -1 to above, to the left -1, and below -1. So, and this is of course similar to all other nodes. If we, for example, place ourselves in this node, we can make the same symbol scheme to illustrate the pairing of vi with vj for all these basis functions close to vi. Note that all other pairing of the basis function with node here with all other basis functions with nodes outside of this region will be 0, because the supports of these basis functions are not intersecting. So we get this principal illustration in for all kind of nodes. You must though be aware of the cases when we are very close to the boundary. Then we of course cannot have insert -1 for example here to the right, due to the fact that we do not have any basis functions with on these associated with these boundary points. And the reason for this is that in our case the boundary is assumed to have 0 boundary conditions, so we do not need to have basis functions associated with the boundary points. However, if we use the Neumann problem, we have to also in these boundary points associate basis functions.